Morning friends. So today we are going to discuss Schrodinger wave equation for a particle in 3D box. Earlier we have discussed the same equation for a particle in 1D box, for 2D box, and today for 3D box. It is just an extension of 1D box only. Okay, nothing else. Like if we have 3D box, that means it may be cubic or any other 3D box where length is, let us take L1 along x-axis and L2 along y-axis and L3 along z-axis. That means that box has length L1, L2 and L3 along x-axis, y-axis and z-axis. Right? These are the lengths. And you know, if L1 is equal to L2 is equal to L3 is equal to L, that is a cubic box. So first we derive for a particle in any 3D box having lengths L1, L2, L3 and can derive for a cubic box. Right? First, just write the equation for a Schrodinger wave equation in 3D. If a particle is in a 3D box, then its equation, Schrodinger wave equation is del square psi over del x square plus del square psi over del y square plus del square psi over del z square. These are the second partial differential of psi with respect to x, second partial differential of psi with respect to y, second partial differential of psi with respect to z plus 8 pi square m upon x square e psi equal to 0. Right? So this is the Schrodinger wave equation for a particle in 3D box. Okay. Now you know this psi is a function of x, y as well as z. Psi is a function of, these are the three independent variables x, y and z. Because box is 3D, so psi depends upon x as well as y as well as z. Right? So let us divide psi into three parts. That x, capital X depends upon x, means capital X is wave function which depends upon x only, y depends upon y only and z depends upon z only. Right? Means psi has three parts, x, y and z. And you know, E is total energy, m is mass of the particle, h is Planck's constant, psi you know wave function. Now E is equal to Ex plus Ey plus Ez. Energy along x-axis, y-axis and z-axis. Energy has also three parts. Right? Now let us write del square over del x square, change psi into x, y and z, x into y into z, right, plus x, y, z upon y square plus x, y, z, z square plus 8 pi square m upon x square Ex plus Ey plus Ez into x, y, z, because this psi that is equal to 0. Right? Is it visible? Yes. Now after getting this value, you know, it depends upon x only. So that means y and z, they depend upon y and z. So they are in means constant for it. So it becomes y into z is like this. For this, it depends, it is differentiated with respect to y. So x and z are constant for it. For this, it depends upon z. So x and y are constant for it. Plus, or we can write rest of the thing on other side. Okay, so it becomes minus, or leave it for time being, 8 pi square m upon x square ex plus ey plus ez into x y z equal to 0. Right? Now divide the whole equation with x, y and z. X into y into z. So if we divide it by x, y, z, x, y, z, x, y, z, x, y, z. So they are cancelled. Here x, y are cancelled. Here x and z cancel. Y and z cancel. So it becomes 1 upon x into del square x upon del x square plus 1 upon y del square y upon del y square plus 1 upon z into z upon del z square equal to minus 8 pi square m upon h square ex plus ey plus ez. Right? We take it on the other side. Now, after getting this, again we can write 1 upon x del square x upon del x square plus 1 upon y del square y upon del y square plus 1 upon z del square z upon del z square equal to minus 8 pi square m upon h square into ex minus 8 pi square m upon h square ey minus 8 pi square m upon h square ez. Right? Now see, this part depends on x only. This part depends on y only. This part belongs to z only. So this 1 upon x into upon del x square. See, this part belongs to x. This part belongs to y. This part belongs to z. So there are 3 independent variables x, y and z. So this should be equal to minus 8 pi square m upon x square into ex and 1 upon y into del square y upon del y square, that is equal to, yes, tell me, you can easily identify it is minus 8 pi square m upon h square e y and 1 upon z into this is equal to minus 8 pi square m upon x square into a z. Right? So we get these three equations now. Now these are three one-dimensional equations. This is for a particle in a one-dimensional box along x-axis. This is for one-dimensional box along y-axis. This is for one-dimensional box along z-axis. So these are three independent equations. That means 3D equation we have converted into 1D. Three 1D equations. Right? So they can be solved like a particle in 1D box. So according to that, x, wave function x, okay, is equal to under root 2 by L1. See, along x-axis, length is taken as L1 into sine nx pi, right, upon L1 into x. So this is derived from 1D box, and along y it is equal to under root, yes, 2 by L2 sine ny into pi upon L2 into y. And third one, these are the solutions of these equations, right? This is equal to under root 2 by L3. How it comes? That you can go through the equation for 1D box. Okay? In that we have derived this equation. How do we get this? Then energy Ex, Ey and Ez. So it is equal to n x square upon 8 pi 3 8 m L1 square n square h square over 8m L square. So along x-axis it is L1, y it is ny square into h square by 8m L2 square. Along z-axis it is ny square h square by 8m L3 square. Nx, ny, nz are quantum numbers of independent variables x, y and z. X, y and z. Okay, and at Planck's constant, m is mass of the particle, L1, L2, L3. These are the lengths along x-axis, y-axis and z-axis of a 3D box. Now, from these wave functions and energies along x, y and z, wave function is equal to x into y into z, right? Product of these wave functions. So that is equal to under root 2 by L1 into sine nx pi upon L1 into x into under root 2 by L2 into sine ny pi over into weight. and last one is under root 2 by L3 into sine and z pi upon L3 into z. Is it visible? Yes. So from here psi x y z comes out to be under root, see, 2 by L1, 2 by L2, 2 by L3. So it becomes 8 upon L1, L2 and L3 multiplied by sine nx pi over L1x sine ny pi upon L2y into sine and z pi upon L3z, right? So this is psi for a particle in 3D box, but for a cubic box, L1 is equal to L2 is equal to L3. Let us take it as L. So it becomes under root 8 by L cube, 8 by L cube into sine nx pi over L1 into x sine ny pi upon L2 y into sine and z pi upon L3 into z. Right? So this is the final equation. You can write it as 2 under root 2 upon L into under root 2. Is it right? You can write it like this. Because if L1, L2, L3, it is like this. Now come to second part, that is energy. So in energy, you know, E equal to Ex, Ey plus Ez. So that is equal to, yes, nx square x square upon 8m L1 square plus and y square x square by 8m L2 square plus nz square x square over 8m L3 square, right? So from this x square upon 8m, it is common, x square upon 8m is common. So nx square upon L1 square and y square upon L2 square plus nz square upon L3 square. This is the energy for a cubic box, for a 3D box having lengths L1, L2 and L3. Now for a cubic box, L1 is equal to L2 is equal to L3 equal to L, that we have already written. So energy is equal to, see, L. So L square comes, it is a common, right? So it becomes x square upon 8m L square and x square and y square plus and z square. So this is the value of energy for a cubic box. Okay. Okay. Now after getting this, this is the value for psi, and last the value for energy, right? Now we know that there are more than one state having same energy. So those states are called what we call them? Degenerate states. We call them degenerate states, and number of states having same energy is called degeneracy. We call it as degeneracy and is denoted by small g. It is denoted by small g. Okay. Now let us plot a graph. It is visible? Yes. Now say nx, ny and nz. These are quantum numbers starting from 1, 1, 2, 3, 4, right? So minimum value of nx, ny and nz, that is 1. Nx, ny, n3 all are 1. Then this is 1, 1, 1. मतलब energy E11 is equal to 3 x square by 8m L square, right? Because x square or 8m L square is same, but nx, ny, nz all are minimum, that is 1. So it is 1 square plus 1 square plus 1 square, so 3. So this is non-degenerate state and having degeneracy is 1. Okay. Now come to second. When we have 1, 1, 2 or 1, 2, 1 or 2, 1, 1. Tell me. They all have same energy because out of nx, ny and nz, only one of them is 2 and other 2 are 1. That means energy of E112 or is equal to energy of 121 equal to energy of 211, and all is equal to just 4 plus 1 plus 1, 6 x square over 8m L square, right? 6 x square over 8m L square, right? Then come to next, that is 1, 2, 2, 2, 1, 2 or 2, 2, 1. So see, energy of 1, 2, 2 equal to energy of 2, 1, 2 is equal to energy of 2, 2, 1, and that is equal to 4 plus 4 plus 1, 2 square plus 2 square plus 1. So 4 plus 4 plus 1 means 9h square over 8m L square, right? So its degeneracy is again 3, and it is 9h square over 8m L square, right? Now energy of 2, 2, 2. Tell me, what is the energy of 2, 2, 2? 2 square plus 2 square plus 2 square. 4, 4, 4 means 12 h square divided by 8m L square. 2, 2, 2. 12 h square, and this is non-degenerate state, right? And so on. You can write for all. So that's all about 3D box. Now let us do one question. It came in 2009. Yes, I have that question. You have to calculate the degeneracy of quantum particle in cubic box, in a cubic box having energy 4 times energy 4 times that of lowest energy is, options are 3, 6, 1, 4. This is question from GATE 2009. Yes. So say lowest energy is 3h square upon 8m L square. So 4 times this energy, that is 12h square over 8m L square, that is this one. So its degeneracy is 1 only, because it is possible for 2, 2, 2 only. So there is no other option, right? If it is written here, it is 3 times, then it becomes 9. So its degeneracy should be 3, right? That's it. Very easy question. If you have this equation, that total energy equal to h square upon 8m L square and x square plus ny square and z square, you can easily solve this question, right? So that's all for the day. Thank you so much for watching this video. Do like, subscribe and share my channel. Happy learning. Jai Hind, Jai Bharat.